Okay, the next thing that we're going to talk about in section 10.3 is we're going to talk about annual percent yield. So the effective annual yield, or annual percent yield, right, APY, different than our APR that we saw in the last example we mentioned. So our annual percent yield, or APY, is a simple interest rate that gives the same amount of interest as a compound rate over the same period of time. To find the APY, basically the formula that we're going to use, it's like investing $1 for a year and then subtracting off the original dollar. So to kind of generally put it into terms that make a little bit more sense, if we look at our APY formula, it looks very similar to our compound interest formula, but then we are subtracting a number back off of there. So when we are using this formula, since we're just thinking of 1 year, we're not going to see a T listed in this formula, but we are going to have an interest rate, and we are going to have an N, a number of compoundings per year. Again, since we're thinking about this all of a comparison from a dollar to another dollar, we're not going to see a P either. So this formula is actually a little bit simpler. And so what as we go through the next example, try to give you a little bit better of a description of what our annual percent yield is than what we see up here. So it is going to be related to our simple interest formula, and when we get our first answer to our first example here, I'm going to try to explain a little bit more what this means up here. Okay, so for example 5, we won't cut our formula off there quite yet. Okay. Determine the APY for $1 invested for 1 year at 4.75% compounded monthly. All right, so again, we're told to use our annual percent yield formula. So make sure we pick the correct formula, and we are looking at something being compounded monthly, right? So compounded monthly again means N equals 12. All right, so our APY formula, 1 plus R over N to the nth power minus 1. Right. Our interest rate, 4.75%. So our R, 0.0475. Right. And our time, again, is 1. Our P is 1, right? So that's why we're not bothering to enter those. And then we're just going to use our compounded monthly, which is that 12. All right, so let's plug these values into this formula and see what happens. All right, we're going to have 1 plus 0.0475 divided by 12 to the nth power, which is also 12, minus 1. When we're plugging these into the calculator, I didn't do a little calculator help bubble for these, but it's going to be pretty similar to what we saw in our compound interest formula. Remember, parentheses are our friend, right? So this is actually a little less complicated. Start with a parenthesis, so make sure we get that guy in there first. 1 plus 0.0475 divided by 12. Close off our parentheses. Use our caret button. Put a 12 there, and then just type minus 1. Right, and we get a huge long decimal here, 0.048547881. So we have 0.048547881. Right, now, looking at this, way too many decimal values there. Right, but thinking about this, looking at our annual interest rate that was given to us at the beginning, where we were compounded monthly, we had 2 decimal values after our percent, so that's how we're going to write this guy out. So if we shift our decimal point back over 2 places, that's going to give us a rounded value of 4.85%. So what this means, right, what our APY means, is that if we were to invest money into an account where our interest is compounded monthly and our interest rate is 4.75%, right? So we could go through, we could use our compound interest formula and figure out what that future payoff is going to be, right? What that future amount is going to be. That is equivalent to if we go back to what we did in the previous section, in section 10.2, and we talked about our simple interest formula. So if we totally scratch the idea of compound interest and say, okay, let's go back to what we did in the last section. Let's go back to our simple interest formula. Right? This percentage compounded monthly is going to work out to be equivalent to a simple interest formula that's compounded at 4.85%. Right? So that's what our APY means. And this is something that's used frequently because it does give us a good basis of comparison. Right? So whether things are compounded monthly, quarterly, annually, semi-annually, whatever the case may be, this gives us kind of a way to mainstream and compare all of our data to one another. Right? So what we're going to look at in example B, consider an account with an APR of 6.75% compounded semi-annually. Find the APY for this investment. All right, compounded semi-annually. A semicircle is half of a circle. So semi-annually means twice a year. So our N is going to be 2. All right, so we're going to keep our same formula. APY equals 1 plus R over N to the nth power minus 1. R equals 0.0675 because it's 6.75%. N is 2. We're going to plug these guys into this formula here. 1 plus 0.0675 divided by 2 squared minus 1. Again, from here, feel free to plug it directly into your calculator. Remember your parentheses. Remember to use your caret button. We get 0.0686. Right? I believe I rounded that off already, which is going to give us 6.86% APY. Notice that in both of these cases, our APY is slightly higher than the interest rate that was originally stated, right? And the reason is because, remember, compound interest means our interest earns interest. So when we're looking at these simple interest, in order to be equivalent, that interest rate would have to be a little bit higher to match up to the interest gaining interest as well. Excuse me. Excuse me again. All right, one last example for our APY. Determine the effective annual yield. Effective annual yield, remember, is APY, right? Our annual percent yield. For $1 for 1 year and the following interest rates, which of the following would we choose to invest our money in? Okay. So 9% APR compounded yearly. So our R is 0.09. Our N compounded yearly means N is going to be 1. Right, so we're going to use our APY formula. Right, 1 plus R over N to the nth power minus 1. Plug these guys in. 1 plus 0.09 divided by 1 to the first minus 1. This is really just going to give us 1.09 minus 1, which is 0.09 or 9% APY. Right, if it's compounded yearly, the interest rate that we have, or that we're given, right, is the same that we say here. Right. Now let's look at our 8.75% compounded monthly. Compounded monthly again means N equals 12. Right, so our APY formula, APY equals 1. Oops. Keep trying to turn my 1 sign into plus signs tonight. 1 plus R over N to the nth power minus 1. Our R, 0.0875. Our N equals 12. Now we're going to plug these into our formula. APY equals 1 plus 0.0875 divided by 12 to the 12th power minus 1. This is going to give us 0.0911, which gives us a 9.11% APY. Again, we can go ahead and keep a couple of decimals after a decimal point for APY. Right, so if we look back to the original question, it says determine the effective annual yield for the following interest rates. So we found our APR. Which of the following would we choose to invest our money in? Well, if we're investing money, the more interest, the better. Right? If we're paying loans, it's the opposite. We want the least amount of interest possible. But if we're investing our money, we want the most amount of interest possible. Right? So in that case, we're going to choose this one, right? Because in this case, even though our APR looks smaller to begin with, because it's compounded monthly, it turns out to be a little bit higher than that one. Right? So our higher APY, right, equals more back from our investment in terms of interest. So as you're going through your homework problems, there are some questions dealing with our annual percent rate, or excuse me, annual percent yield. As you're working through these, again, make sure you're using the formula, make sure you're plugging stuff into your calculator correctly, and make sure you are writing your final answer in the correct forms, written and rounded to the correct number of decimal values.